Hello, NE204. We're going to have an online lecture today where we're going to continue our discussion of statistical model of spike train data. So what we talked about last time was introducing this statistical model of action potentials or spikes, and we considered modeling these spikes as coin flips, and we considered this idea of the Poisson model, and we went into that last time. And remember how we got these data? Our collaborator, a graduate student here at BU, was collecting activity from a single neuron in the hippocampus. And so what he's able to do is stick this electrode, which we can just barely see here as this faint whisper in the figure, into a single neuron. So he's able to patch this neuron and record its voltage activity as a function of time. He collects data in multiple trials, so he'll stimulate the neuron and record the activity as a function of time. He'll then stimulate the neuron again in some way, maybe by dumping a chemical on the slice and record the activity as a function of time, and do this for a third trial and so on, all the way up to K trials. Each time he'll observe that neuron for half a second, so the length of the trial is 0.5 seconds. And remember, what we're showing here is an abstract representation of the spiking. So here we're showing tick marks to indicate the spike times. The voltage trace that he's actually observing is much more complicated, and we'll get into that later in the semester.